Let's take a look at the kind of reasoning that goes into hypothesis testing as we're working toward our goal. So if we're going to do hypothesis testing, there's different layers of that based on the kinds of conclusions we're looking to draw. Probably one of the most common that we do involves looking at a single population. Again, a population isn't necessarily people. We often use that in our examples when we talk about populations of data going through, but it could be just all of the devices that are manufactured in a single shop, or all the shipments that come through a certain warehouse, or all the people, the retail customers that come through a store on a given day. So it's people or things or something we want to measure and make some kind of generalization about as we go. And the way we do that in hypothesis testing is we draw a sample of data from the population, typically randomly, so that we know it represents the sample and we can generalize to the sample. And the reason we call it hypothesis testing is because usually there's something we think we know about the population. Usually it's mean, maybe it's variance or standard deviation. So we know something about the hypothesis. What we typically get out of our sample is an average value, or what's referred to as the expected value coming through. Sometimes we deal with the variance coming through, but typically less often than we do the expected value coming through. And our ability to take that X bar and draw conclusions about whether our mu was correct or not, whether it's on target or not. The null hypothesis is always that we know what it is. We reject that hypothesis if the sample tells us that we couldn't have gotten this sample the way we got it going through as we went. So that's a single sample hypothesis test. It's where we start out with the basic reasoning of hypothesis tests, but it's not the most mature in the world, but it teaches us the basic math of how to do the underlying statistics and probability to make that true.